Welcome to Study Loop.
Here, we know that for part A, to find the radial acceleration, this would simply be equal to v squared over r. And so this would be equal to 6.00 meters per second quantity squared divided by 14.0 meters. This is equaling 2.57 meters per second squared. The direction of this would be upwards. Now for part B, the magnitude of the radial acceleration would be the same as for part A. So this would be 2.57 meters per second squared. However, because now the direction towards the center of the circle is downwards, so because of that change in direction, again, the direction towards the center of the circle is downwards, the acceleration at this point in the motion would be 2.57 meters per second squared, but not upwards, downwards. This would be your answer for part B. And then finally for part C, we have to set up an equation where we know that the velocity would be simply equaling the distance for one revolution. So we could say the circumference of the proposed circle, 2 pi times r, and then divided by the time it takes to complete one cycle, or in this case, one circle, t, the period. And so solving for the period, this would be simply the circumference of that proposed circle, or 2 pi r, divided by the linear speed with which you are traveling. This would be equaling to 2 pi times 14.0 meters, and this would be divided by 6.00 meters per second. And we find that here the period is equaling approximately 14.7 seconds. This would be our period for part C. That is the end of the solution. Thank you for watching.